Hello guys. I came into our classroom to clear out some stuff, and while I was putting away some glassware I thought I should perhaps show you a demonstration. The past couple of days I've asked you to think about how we know atoms exist. Albert Einstein's explanation of Brownian motion is really considered by most people the definitive reasoning behind it. His explanation of how pollen was vibrating around. So I'm going to explain something here. Here I've got 2 beakers of water. I'm going to put a drop of food dye in the first one here. Actually, 2 drops. Look at that. Okay. Now you notice the dye falls to the bottom, but not all of it. And over time, you can imagine what's going to happen here. The dye will eventually spread out evenly through the entire beaker. But now, why is that happening? How come it's going to spread out and eventually the beaker of water will have a pale green color to it and not just spots where there's more dye than others? Right now you can see sort of strands of dye concentration. That will vanish over time. Okay, I put this on a white tray so you would see it better, but I think if I pick it up you can kind of get a sense that there are strands of where their dye is heavy and other spots not. But over time, if we sit here and let this sit for a day or two, not even a day or two, probably just a couple of hours, eventually it'll be entirely a nice pale green all the way through. And this is analogous to Brownian motion, why those bits of pollen are vibrating. Why is the dye being dispersed throughout the beaker of water? Well, if water is made up of hydrogen dioxide molecules, H2O, that are vibrating around, they're going to bump into the dye molecules. And the kinetic energy, the vibrations of those water molecules, random as they are going to bump into the dye molecules and knock them around and disperse the dye throughout the entire beaker. And if at different temperatures, this would happen at different rates. Albert Einstein explains it mathematically. He doesn't do this experiment, but he says if the solution that the pollen is put in when it's looked under the microscope is made of molecules that's vibrating, well, then they're going to bump into the pollen molecules and cause the pollen molecules to vibrate. And he explains it really, really well and mathematically proves it. And a couple of years later, it is tested. All right, Einstein writes his paper in 1905. It is tested, I think, in 1908. Remember, no one really pays attention to his papers in the beginning. And then, wow, it seems like, hey, the kinetic molecular theory is experimentally proven. So you can hopefully clearly see now that this dye is definitely having fewer areas where it's heavy but more spread out. Einstein explains that with kinetic molecular theory. Why is this happening? And if you were to do this with cold water, it would happen slow. If you were to do this with warm water, it would happen faster. But the reason that the dye disperses is kinetic molecular theory. Again, if I stir this, speed up the process, now you get that nice even distribution. That is mathematically explained by Einstein's math of kinetic molecular theory. And once again, two more drops. You can kind of see, all right, yeah, there's the dye is falling to the bottom and spreading out, but there are regions that are concentrated. But it's not going to stay like that. It's not going to stay as a single drop. It disperses, it spreads out. And why does it spread out? Because the water molecules that surround the dye are bumping into it. And you can't explain, or you can't really predict where the dye is going to be. You can't really know where the dye is going to be. This comes into chaos theory in math, fractals and that kind of stuff. But you know that the dye is going to evenly distribute itself over time. And the reason that happens is because the water is made of atoms that are vibrating, and they're going to interact with the tiny particles of the dye that are also vibrating, and they will disperse. So this is analogous to the Brownian motion. Why are the bits of pollen vibrating around? If we were to look at this or magnify this several thousand times, we would see little drops of dye being pushed around by water molecules. We don't see that now, but you get the idea, right? You can see the strands, but they're dispersing. They're getting less and less strands, and over time it'll distribute itself nice and evenly. And the reason that happens is because the water molecules, that's right, the water particles are vibrating. Everything that's above temperature of absolute zero, negative 273 Kelvin, everything that's above that temperature is vibrating. It has kinetic energy. And so those particles are vibrating, bumping into the dye particles that are vibrating. And the explanation you can prove mathematically. You can match mathematics to your observations. And that's really what happens. And if we let it sit there long enough, eventually, I helped this one stir this one around, but this is what that's going to look like in a couple hours. All right, I hope that helps explain Brownian motion a little bit to you, and that's all we got.